yesterday in our discussion, then today, we're going to be talking more about some absolute value inequalities. Okay. We said yesterday we started with absolute value equations, and there were two solutions, weren't there? Because we said that absolute value is the distance from zero, and this notion of distance, we could go to the left down into the negatives, or we could go to the right. So just bearing in mind that, my screen share thing is coming up here. Come on. There we go. Now we're cooking. All right, you guys should see that here in just a sec. Bearing in mind that two possible solutions, right? We said the first step was to isolate absolute value. Okay, so Alex, what do you want to do to both sides? We don't want to mess with the 4. It's on the inside of the absolute value sign. Think about it like an onion. Handle that outer layer. What do you want to do? It's already being added, so instead of adding, we're going to use inverse, which would be subtraction. Good. So we're going to subtract.
Say like those lines were like parentheses?
Yeah, they are very much like grouping symbols. Absolutely.
So wouldn't you do those before?
All right, so good question. Can I do anything inside this grouping symbol? Could I combine like terms, for example? I cannot. Right. And absolute value is unique because like if this was 2/3 x minus 4 in parentheses and then plus 11, we would go ahead and say, well, those parentheses are superfluous. We don't need them. They're extra. No big deal. And we would go ahead and combine the 4 and the 11, right? But in this case, absolute value actually has an operation involved with it as well. It's not just a grouping symbol. It's a grouping symbol with an operation. So I have to consider that operation before I do anything like deal with the 4. All right, so if we subtract 11 from both sides, we're going to get -8 on the right. And we got absolute value on the left. And what does that mean? When we look at a problem, what does that mean? An absolute value problem. We're just looking at it where it says, okay, this expression, 2/3 x minus 4, is this far away from 0 on a number line. Now, I don't know about you, but when I consider distance, I consider it to always be what? Positive. Positive. Distance isn't negative. It wouldn't make sense for me to say that I live over in Somerville. I live -31 miles away. That's nonsense. So how can I say that 2/3 x minus 4 is -8 units away from 0? What the dump is -8 units away? Okay, it doesn't make any sense. And so here's one challenge for it. Right now, I would go ahead and stop and I would say this equation has no solution. Okay, but let's just pretend like we didn't know that. We didn't know that absolute value can never be negative. Okay, by the way, I would write that down. Absolute value is non-negative. Okay. Let's suppose that we wanted to split it up, much like we did yesterday, where we said, okay, well, 2/3 x minus 4 equals -8, or 2/3 x minus 4 equals +8. Let's just pretend like we did the same thing we did yesterday. Okay. I would add add 4 to both sides on this first one, and then multiply by the reciprocal 3/2. So we got x equals -6. And then over here we'd add 4, we get 12. Multiply again by the reciprocal 3/2, we get 18. And it's very tempting for us to say, oh yeah, I got my two answers, -6 or 18. But what are we supposed to be able to do with those answers? Yeah, a solution to an equation is a set of all numbers that when plugged in for a variable or variables makes a what? A true statement. But if I plug in -6, watch what happens up here. If I plug in -6 in for x, let's try this in red. 2/3 times -6. That's going to be -4 minus 4 is -8. What's the absolute value of -8? 8. So I've got 8 plus 11, that's 3. Is that a true statement? Heck no. Okay. And it would be the same deal if I plugged in 18. 18 Divided by 3 is 6 times 2 is 12. 12 minus 4, again, is 8. 8 plus 11 is not 3. So these are bogus answers. And if you had gotten those answers, you just simply forgot that absolute value is non-negative. And it's actually kind of nice. Anytime you get an equation where you're told that the absolute value expression equals a negative number, just stop right there and say, no, it doesn't. No solution. There is no such number. Okay. All right, questions about example 2. Example 2 kind of being a little bit of an outlier, right? Kind of a weird one. Yes, sir.
How do you know so early that it wasn't?
That it was no. So the question is, how did we know so early that it was no solution? Okay. Whenever you do that first step of your process, right there, step number 1, isolate the absolute value expression. And so Alex had told us, hey, let's subtract 11 from both sides. When I get to this step where absolute value is by itself, whatever equals over on the right-hand side, if it is negative, then I throw on the brakes and I say, stop right there. I can't do anything else because absolute value is never negative. Okay, really important question that that Tiago just asked. So good deal. All right, so let's look at example 3. This is one last example of solving absolute value equations, but this one's a little bit different, Quentin. What's different about this one? What do you notice that's kind of strange about this one compared to the other two? Anything stand out to you? Drew, what about you? You notice anything? A little bit louder, please. What equals each other? Oh, there are 2 absolute values. Now, in the first equation, there was only 1. And in the second equation, there was only 1. And yet here, there are 2 absolute value equations. So here's how we handle a situation where you've got an equation that has 2 absolute values. Just get one of them by themselves. First, isolate the one. Okay, split it up, as I'm going to show you, and then isolate any remaining ones. Now, we also have, in this case, a special case that I've made a note to the effect of, that you should definitely write this down, that if we've got 2 absolute values that actually equal each other, there's nothing else going on the outside, if they actually equal each other, then what you can do is you can set their arguments equal to each other. You can say that, in this case, 5x minus 1 equals 2x plus 3. Or you could say 5x minus 1 equals the opposite of 2x plus 3. Okay.
Your screen is like really behind, so it won't show up on the screen till like 10 seconds later.
I got some kind of crazy lag here, don't I?
Yeah.
All right, y'all bear with me. I'll look into it. Hold on. We had some of this happening yesterday for some reason, too. I'm not exactly sure. I'm trying out some new masks that my wife made for me. Yesterday's was fantastic. It was big, covered my whole face. This one is a little bit too small. So I keep yanking on it and pulling on it. Trying to give myself a little bit more comfort here. Oh yeah, man, this is big time lag, and I click on a button and it takes 30 seconds for it to activate. Well, I'm sorry, Lewis, was that you that had made that comment? Yeah. All right. I'm sorry you guys are having this kind of lag. Nate says he's having internet issues. Join the club, bub. All right. Well, we'll try and soldier on, and if worse comes to worse, you guys, as you're sort of catching on this lag, you can play catch up later and just watch the video in real time too. But do stay here and on the call and at least listen to what's going on. You know, this notion of an absolute value expression equaling another absolute value expression, okay, is actually kind of easy. You just write it twice, right? Once where the arguments equal each other, and once where the argument of the first one equals the opposite of the argument of the second one. All right. So let's go ahead and run through these in blue. We can solve these out. Let's subtract 2x from both sides. And add 1 to both sides. So we got x equals 4/3. Over here, I need to distribute my negative first. So negative 2x minus 3. And then I can add 2x to both sides and add 1. And divide by 7. So those would be my two answers. 4/3 or -2/7. Again, just take your time, show your steps, peel back the layers, combine like terms, all that good stuff. Okay. Now, like I was asking Quentin and Drew, and at the beginning of the problem, we should notice, ooh, this was a little bit different. This one's got two absolute value expressions. Okay. So like our normal process, if you remember back up at the top when we started discussing this yesterday, our normal process for solving them, that first step, if there's a couple, you might ask the question, well, okay, which one do I isolate? For example, okay, suppose I got absolute value of x plus absolute value of x plus 6 equals 8. Okay. So in this example, you might say, all right, coach, which one should I isolate? Step 1 says isolate the absolute value expression. Which one? It really doesn't matter, but I'm going to give you my suggestion, okay? Here's my suggestion for you guys. Pick the one that's more complicated. Pick the one that's got a little bit more junk in its trunk, so to speak. Okay, which one's got more going on here? Absolute value of x plus 6. Get it by itself first. Okay? So what would I need to do, Charlie, to both sides to get absolute value of x plus 6 by itself? Subtract what? Don't you dare subtract 6. No, sir. That absolute value sign is like a grouping symbol, and it is joined to that x and that 6 together. Look at this as though it is a, b equals c. I'm asking you to get b by itself. What do you do to both sides? Subtract what? A, B, or C, bro. Look, A, B, or C. What do you do to both sides? Subtract A. So in this case, my quote unquote, my A is what? 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 The absolute value of x. Okay, y'all are crazy. Y'all cuckoo kangaroo up in here. You guys ever heard of cuckoo kangaroo, by the way? No? Oh, my kids freaking love cuckoo kangaroo. It's just a couple of guys on YouTube that make children's videos, like dinosaur stomp. Pick up your feet and stomp it, and then a little dance you do with it. Or all I eat is pizza. That's a classic. I've got cheese on my fingers. It's a great one. But their all-time favorite is the gobble wobble. It's this dance about being a turkey at Thanksgiving. You ever heard it? Oh man, the gobble wobble. It's a. Do kids still say lit? It's a lit tune. Okay, I know I'm not using that in the right context, but whatevs. So, all right, y'all crazy if you think just subtract x. We want to move that whole absolute value of x over there to the other side. All right, so we're going to subtract absolute value of x from both sides. Okay. So now I've got absolute value of x plus 6 equals 8 minus absolute value of x. Now, step 2 says write the equivalent equations. Okay, so let's remember what that means. If I've got, over here in red, if I've got the absolute value, let's just say the absolute value of A equals B. That means that A lives B spots away from 0 on a number line. That means that if I drew out my number line here and here, there's 0, there's B, there's negative B, and we're saying that A could equal either one of those. I did this yesterday. All right, so A is going to either equal negative B or A is going to equal positive B. You just equate those two values. All right, now that's dealing generally, okay? If I want to come back over here in green and deal specifically, what's my quote unquote my A, is I'm saying, all right, absolute value of x plus 6 means that x plus 6 lives this far away from 0. So that's either 8 minus absolute value of x or the opposite of 8 minus absolute value of x. Okay? So in other words, if I said absolute value of x equals 7, you'd say, oh, well, then x equals 7 or negative 7. X could live 7 spots to the right, 7 spots to the left. I would account for both of those. So what we're saying here is we want to set the right-hand side and then the opposite of the right-hand side. That's how we're cooking up our two examples there. Okay? Again, I'll remind you what the basic with a basic concept here. Check this out. Look, if it's absolute value of x equals 7, then I oftentimes will tell students, drop the bars and rewrite the expression or the equation, x equals 7. And then I say, all right, we'll drop the bars and rewrite the equation, but just change the sign of the other side. So -7. Okay, and then you would have your two answers that way. That's all we're doing. We dropped the bars over here on the left. We rewrote it once as is. And then we dropped the bars over on the left. We rewrote it a second time, and we changed the sign of the right-hand side. Okay? Looks like somebody has made a comment in ye old chat. Let's see what this is. It'll probably take another daggum 30 seconds. All right, so in dealing with this equation right here, this top one in green, what could I do to both sides? Well, rinse and repeat. Is there still an absolute value expression in that, or an absolute value term in that equation? Yeah, I see absolute value of x right here. So I need to rinse and repeat. I need to repeat the process. Let's isolate that, get it by itself. What would you do to both sides to get itself? All right, so we could subtract 8. Now, I'll be honest with you. I wouldn't. You could do it this way. I wouldn't do it this way. But if you subtract 8 from both sides, you get x minus 2 equals the opposite of absolute value. And then what would you do next, Jake? You want to get absolute value, not opposite of absolute value. So just divide everything by -1. Let's divide everything by -1. All right. I'm actually going to scooch this over just a little bit and give myself some more room. And then let's do this. Delete. All right. So Jake had suggested subtract 8 from both sides, and then I said, all right, if we do it that way, let's divide everything by -1. So we got absolute value of x equals 2 minus x. So the 2 was negative, it's positive now, and the x was positive, now it's negative. And then look at what we would do. We'd repeat the process. We'd say, okay, well, x equals 2 minus x, or x equals x minus 2, and we'd run it that way. Okay. Same thing over here. We would distribute our negative. We get -8 plus absolute value of x. In this case, we would just add 8 to both sides. And get x plus 14 equals absolute value of x. All right. And then what do our rules say again? Our rules say, okay, drop the bars, rewrite it. So x equals x plus 14, or drop the bars, rewrite it, and change the sign of the other side. In either case, look at what we've got. We've got 1, 2, 4 little equations that we would want to solve for this one. And it gets compounded. I'm going to actually stop there because I'm getting this glassy look in y'all's eyes like, what in the dump is he even talking about? And so we'll slow down and we'll talk about this after spring break, some of these equations that might have more than one absolute value expression in them. All right. I don't want you feeling like you're having to bite off more than you can chew right now. Suffice it to say, some of these easier ones that have the one absolute value, we follow our steps, we take our time. Graphing it out can help, just like we did in example 1. And then down here in example 3, we had a couple of them that were equal to each other. Okay. All right. I do want to get a couple of easy inequalities in because we've just been talking about equations up to this point, right? So let's talk about what do I do now if it's absolute value inequality. And the steps are going to be very similar to how we handled the last couple of examples. All right. First step is isolate absolute value. It already is by itself here, so that step is done away with. Now here's where we do step 2. Step 2 is a little bit different. Okay. We're going to drop the bars, rewrite it. We're going to drop the bars, rewrite it, change the sign of the other side. Okay. But we want to first determine what kind of word we are dealing with. We want to determine what kind of word we are dealing with. Okay. We're going to either have an and, or we're going to have a what? Or. Those are our two options. Now, how do I know which one is which? A mnemonic device shall help us. If you have a less than, if you have less than or equal to, that's dealing with the word and. How do I know that? Because it's pronounced less than or equal to. If I've got greater, greater than or equal to, guess what? That's going to be an or. Did you hear how I pronounced that? So when we talk about our little mnemonic device here, if we see less than, then we think and. If we see greater, I know that's misspelling. If we see greater, and that's what that's our mnemonic device for which word we're using. So which one do you think it is over here in black that we're dealing with? Is it an and or is it an or? It's an and. And again, I'm a visual guy, so watch this. If I draw this out on the number line, okay, what does absolute value less than 7 mean? What do you think, Tiago? Or when we think of absolute value of x, that means how far away is x from 0 on a number line? It is somewhere between -7 and +7. Because think about it like this. If I said, hey, one of you guys, do y'all live less than 7 miles away from Christian Brothers? Anybody live less than 7 miles away from Christian Brothers? Okay. So think about what that means. If I took a map and I drew a big, y'all seen this on like the cop show, right? They're like, put out a APB and draw a 7-mile perimeter around the site and don't let anybody out. You know, what do they say? They say, we're going to keep it within 7 miles. So his distance is less than 7. That means that he could go anywhere to the right, he could go anywhere to the left, up to, but not including 7 on this one. So what this means for us is that x could be greater than -7. Now, should I use an and or should I use an or? You absolutely may. I got to make sure it's got batteries in it for you.
What's up, guys?
This one does not. Jake Workoven, ladies and gentlemen. All right, this one's got a jacked up screen. Does it have to be a graphing calculator?
I don't. I just need something to do math.
All right. Let's see here. Where's the daggum clear button on this? You know what? Tried and true. Let's go with this one. Boom. You got it.
Cool. Thank you. I'll bring this back after.
No worries, man. Hope it helps. Did y'all tell me what word we needed to use?
Or.
Less than. Less than. So we're going to say and then x less than 7. A picture can really help us there. And the way that I could consolidate both of those is using just the notion of being between. I'd say, okay, well, x is between -7. Alex, I'll raise it up. -7 and 7. All right. Now, I know I feel like y'all probably feel like I have crammed all of this in on you. Trust me, when we come back from fall break, we're going to slow it down, take our time, okay? But I do want to make sure you guys understand absolute value inequalities. Really, if you keep a step-by-step process in mind, you keep in mind which word we're using, you're going to be straight. I think I'm probably going to need to let you guys go. So, hey, y'all have a wonderful day. I won't see you again for a week. Be safe, be healthy, be happy, and live Jesus in our hearts. All right. Thank you, guys. Hey, guys. Jacob Wilson. Aha! I've got your ID card. I'm glad that you remembered because I totally forgot, my man.
Thank you very much.
Good to see you in person. It's been a while.
Yeah, it has. You too.
Oh yeah, my mom wanted me to ask if you know Luke Rawlings.
Yeah, I know Luke. How do I know Luke?
He used to teach here.
Yeah, that's right. I think he used to teach math here.
I'm wearing his home.
Dude, nice. Throwback. James, have a great day, buddy.